Trigonometry review. Trigonometry is a branch of mathematics that deals with the study of angles, triangles, and the relationships between their sides and angles. The 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. They are commonly abbreviated as sin, cos, tan, csc, secant, and cot respectively. Here's a brief overview of what each function represents. Sine, sin. The sine of an angle is the ratio of the length of the side opposite to the angle to the length of the hypotenuse of the triangle. Cosine, cos. The cosine of an angle is the ratio of the length of the adjacent side to the angle to the length of the hypotenuse of the triangle. Tangent, tan. The tangent of an angle is the ratio of the length of the side opposite to the angle to the length of the adjacent side of the triangle. Cosecant, csc. The cosecant of an angle is the reciprocal of the sine of the angle, i.e., csc theta equals 1/sin theta. Secant, secant. The secant of an angle is the reciprocal of the cosine of the angle, i.e., sec theta equals 1/cos theta. Cotangent, cot. The cotangent of an angle is the reciprocal of the tangent of the angle, i.e., cot theta equals 1/tan theta. These trigonometric functions are used to solve a wide range of problems in geometry, physics, engineering, and many other fields. It is important to have a clear understanding of these functions and how they are related to each other in order to apply them effectively in problem solving. Explain the Cartesian coordinates and quadrants. Cartesian coordinates are a system of describing the position of a point in a plane using two numbers, usually denoted by x, y. This system was developed by the French mathematician René Descartes in the 17th century, and it has become an essential tool in mathematics and many other fields, including physics, engineering, and computer graphics. In the Cartesian coordinate system, the plane is divided into 4 quadrants by 2 perpendicular axes, the x-axis and the y-axis. The x-axis represents the horizontal dimension, while the y-axis represents the vertical dimension. The point of intersection of the 2 axes is called the origin, denoted by 0, 0. The positive x-axis extends to the right of the origin, while the negative x-axis extends to the left. Similarly, the positive y-axis extends upwards, while the negative y-axis extends downwards. Each point in the plane can be uniquely identified by its Cartesian coordinates, x, y, where x represents the horizontal distance from the origin to the point, and y represents the vertical distance from the origin to the point. The values of x and y can be positive, negative, or 0, depending on the location of the point relative to the axes. The 4 quadrants of the Cartesian plane are named as follows. Quadrant I. This quadrant is located in the upper right portion of the plane, and it contains points with positive x coordinates and positive y coordinates. Quadrant II. This quadrant is located in the upper left portion of the plane, and it contains points with negative x coordinates and positive y coordinates. Quadrant III. This quadrant is located in the lower left portion of the plane, and it contains points with negative x coordinates and negative y coordinates. Quadrant IV. This quadrant is located in the lower right portion of the plane, and it contains points with positive x coordinates and negative y coordinates. The quadrant in which a point is located can be determined by the signs of its x and y coordinates. For example, a point with coordinates 3, 4, is located in quadrant I, because both its x and y coordinates are positive. A point with coordinates -2, 5, is located in quadrant II, because its x-coordinate is negative and its y-coordinate is positive. Doing the best you can explain angle measurements in degrees and radians. Angle measurements are used in geometry to describe the rotation or inclination of one line or plane relative to another. The 2 most commonly used units of measurement for angles are degrees and radians. Degrees. In the degree measurement system, a full circle is divided into 360 equal parts, each part being 1 degree. A degree is further divided into 60 minutes, and each minute is divided into 60 seconds. Thus, an angle can be expressed as a combination of degrees, minutes, and seconds. For example, an angle of 30 degrees, 15 minutes, and 20 seconds can be written as 30 degrees 15 minutes and 20 seconds. Radians. In the radian measurement system, an angle is measured in terms of the ratio of the length of the arc subtended by the angle to the radius of the circle. Specifically, an angle of 1 radian is defined as the angle subtended by an arc that is equal in length to the radius of the circle. Thus, a full circle contains 2 pi radians, or approximately 6.283 radians. To convert from degrees to radians, we use the formula, radians equals pi/180 degrees. For example, an angle of 45 degrees can be converted to radians as follows, radians equals pi/180, 45 equals pi/4 radians, or approximately 0.785 radians. To convert from radians to degrees, we use the formula, degrees equals 180/pi radians. For example, an angle of pi/3 radians can be converted to degrees as follows, degrees equals 180/pi, pi/3 equals 60 degrees. In summary, both degree and radian measurement systems are used to measure angles. The degree system is based on dividing a circle into 360 equal parts, while the radian system is based on the ratio of the length of an arc to the radius of the circle. Converting between these two systems involves using the appropriate conversion formula. What about GON? GON is another unit of measurement for angles, also known as gradian or grade. It is used less commonly than degrees or radians, but it is still used in some fields, such as surveying and navigation. In the GON measurement system, a full circle is divided into 400 equal parts, each part being 1 GON. Thus, 1 GON is equal to 0.9 degrees or pi/200 radians. The advantage of using the GON system is that it allows for easier and more precise calculations, especially when working with angles that are multiples of 90 degrees. To convert between GON and degrees, we use the formula, degrees equals GON/400, 360. For example, an angle of 50 GON can be converted to degrees as follows, degrees equals 5400, 360 equals 45 degrees. To convert between GON and radians, we use the formula, radians equals GON/400, 2 pi. For example, an angle of 100 GON can be converted to radians as follows, radians equals 100 400, 2 pi equals pi/2 radians, or approximately 1.57 radians. In summary, GON is another unit of measurement for angles, based on dividing a circle into 400 equal parts. It is used less commonly than degrees or radians, but it can be useful in certain fields for more precise calculations. Explain Pythagorean theorem. The Pythagorean theorem is a fundamental result in Euclidean geometry that relates the lengths of the sides of a right-angled triangle. It states that, in a right-angled triangle, the square of the length of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. In mathematical notation, this can be written as c squared equals a squared plus b squared, where c is the length of the hypotenuse, and a and b are the lengths of the other two sides of the triangle. The Pythagorean theorem can be used to find the length of any side of a right-angled triangle, given the lengths of the other two sides. For example, if we know that one side of a right-angled triangle has length A equals 3 and another side has length B equals 4, we can use the Pythagorean theorem to find the length of the hypotenuse as follows. c squared equals a squared plus b squared, c squared equals 3 squared plus 4 squared, c squared equals 9 plus 16, c squared equals 25, c equals 25, c equals 5. Therefore, the length of the hypotenuse is c equals 5. The Pythagorean theorem has numerous applications in mathematics, physics, engineering, and other fields. It forms the basis for the distance formula in 2- and 3-dimensional coordinate geometry and is used in trigonometry to relate the length of the sides of a right-angled triangle to its angles. Explain the unit circle. The unit circle is a circle with a radius of 1 unit, centered at the origin of a Cartesian coordinate system. It is an important tool in trigonometry, as it allows us to easily visualize and understand the relationships between the trigonometric functions and angles. The unit circle can be divided into 4 quadrants, each containing a 90-degree angle. The positive x-axis and positive y-axis divide the circle into 4 equal parts. Each of these parts is called a quadrant, and is labeled 1, 2, 3, or 4, starting from the positive x-axis and going counterclockwise around the circle. To understand how the unit circle relates to trigonometric functions, we can imagine a ray that starts at the origin and intersects the circle at a point, x, y. The angle between this ray and the positive x-axis is called the angle of rotation, and is denoted by the Greek letter theta, theta. The coordinates, x, y, of the point of intersection can be written in terms of the angle theta using the trigonometric functions sine and cosine. X equals cosine theta, y equals sine theta. The unit circle can also be used to find the values of the other trigonometric functions, such as tangent, cotangent, secant, and cosecant. For example, tangent is defined as the ratio of sine to cosine, so we can write tangent theta equals sine theta, cosine theta. The unit circle can be a useful tool for solving trigonometric equations and for visualizing the relationships between different trigonometric functions and angles. Thanks for watching. Please like and subscribe. Have a great day.